Pandas Introduction. In this section, you will develop a basic understanding of the Pandas library, as well as learn about and practice with fundamental programming tools such as methods, parameters, arguments, attributes, and index values. You will also work with the Pandas series and data frame objects. In the end, we will present the Pandas documentation and will show you how you can navigate through it. Perhaps there is no particular order in which this material should be taught. However, all these concepts are strongly interrelated, which means that making the first step is the most important thing to do. So, let's start with an introduction to Pandas, and then we'll explore the rest of the topics one by one. What is Pandas, and what problems does it solve? According to its documentation, Pandas is an open-source library which provides high-performance, easy-to-use data structures and data analysis tools for Python. Let's shed some light on this definition. First of all, the name of this library is derived from the phrase panel data, which is a term used in econometrics for datasets that include multiple observations over multiple periods of time. To put it simply, this term is used for a certain type of data tables. Second, we must note that unlike NumPy or Matplotlib, for example, Pandas is not one of the essential components of the Python scientific computing tools. So, it is largely used by the data science community because it makes our work much faster and easier. And while Pandas is a great package, please remember it is built on top of NumPy, and it steps on its computational abilities. In other words, you can think of Pandas as a library that takes advantage of the NumPy array structure, which contributes to the fast execution of mathematical operations, such as calculating the mean or the cosine of certain data, provided that the values involved are all numeric, of course. In any case, what is important to remember is that Pandas requires NumPy. So, unless you have installed the NumPy package beforehand, you won't be able to use Pandas. Alright, technically, most of your work in Pandas will be done with the help of two high-performance and easy-to-use data structures. These are the Pandas series and data frame objects. You can imagine the series object as a single column data, or a set of observations related to a single variable. Thus, the series object corresponds to a one-dimensional array structure from NumPy. What about the Pandas data frame? Well, it's just like the series object, but usually with several columns. That's also why the data in a data frame is organized conceptually and literally as a collection of series objects, which also means that it contains observations related to one or several variables. Hence, the information in a data frame is organized into rows and columns, which is why it corresponds to a two-dimensional NumPy array structure. Okay, this all sounds great, but is there any difference between working with a series or a data frame? Well, the general principles of working with series and data frames are identical, although there are some differences. Therefore, a certain tool that is applicable to a series will most probably be relevant to use on a data frame as well, or vice versa. However, we will make sure to point out such rare and relevant cases to you wherever they occur. Good. So, we can say that we know what Pandas is. And what about the second part of the question we asked earlier? What problems does the Pandas library solve? We already said that Pandas makes the experience of doing data analysis in Python much faster and easier. In addition, it enhances your analytical work if your dataset contains missing values, or when you have to combine information across several datasets. Not only that, but Pandas has the ability to import data from and export data to an extensive set of file formats. Finally, while NumPy is the library to opt for when it comes to dealing with numerical calculations, Pandas has been specifically designed to help you if you have to analyze datasets containing multiple types of information. In other words, if you need to store not only numbers, but also strings, Boolean data, date or time values, a Pandas series or a data frame is the way to go. On that note, you can think of everything we shared so far in this lecture as material that is essential to know as programmers. As analysts, though, you must remember that it is crucial to preserve data consistency. Put it another way, you must have data values of a single type stored in your series object or in each column of your data frame. For instance, this means that in your series or in the different columns of your data frame, you should only store integer values or only floats. Or, if you need to have text values only, your series or data frame should only contain strings. However, you shouldn't mix them. Having integers, floats, and strings in the same column will be confusing, not just for whoever is working with the data, but will also lead to errors and inconsistent results at a later stage of your analysis. All right. Hopefully, our introduction to pandas gave you an idea why it is one of the libraries that have turned Python into a reliable and powerful data analysis environment. The good news is that its constant updates and maintenance suggest that this will continue to be the status quo for years to come. Before you start working with pandas, we have to make sure that you've set it up on your computer correctly. That's what we'll do in our next video. See you there.